Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there.
Alright. Sorry about that. How annoying. Okay. Well, hopefully everything will play nice. Now I've got to wait for it to start up again. Okay, now it seems to be working fine. But anyway, so where was I? Yeah, so I'm trying to kind of clean up this grass system, so I decided to just go ahead and rewrite all the shaders, taking everything that I've learned while researching it and trying to make it more easy to, I guess, show how to, for other people to create it. And at the same time, I wanted to try out a new wind system, which I've been slowly working towards. The main thing that has to do with that is instead of using matrices to, I guess, define the way that grass sprouts point, where I'm going to use quaternions, so that way I can just interpolate between like a base rotation and a tip rotation. So last time we got the terrain to work. So here you can see the grass is pointing away from the terrain. So yeah, and also there's a random bend angle. So I want to just make sure all that is working fine, and then we'll be able to add in some wind, I think. At least that's the plan. So let's see here. Okay. Alright, I think I'll just like put everything in here, and then once we've got it working, I'm going to need to clean up this function because some of the stuff will be shared. But okay, so tangent space, and then I add in a random bend angle. Did I attach it to a material already? Or a property? No. Okay, so oh yeah, okay, so here it's just hard-coded for the maximum bend angle to be pi over 4. So I can do blade max bend angle, and then we'll add that to the shader. Okay, and I guess I'll just make it be a multiplier of pi. So okay. And then here, I can use that instead of this hard-coded value. Okay, and mostly I just want to make sure that it'll update dynamically. Okay, yeah, so when it's at 0, they all stand up straight from the terrain. Alright, so that's good to see. Although I am okay, so if this is supposed to be a multiplier, oh right, I need to multiply it with pi. Okay, because I was gonna say that 1 times pi is 180 degrees. So yeah, we should see stuff like turn upside down, which probably we don't really want to happen, so but okay. So that's working. Okay, so I guess next thing I want to do is we need to add tessellation to the graphic shader or material shader, so that way we can see, like, because right now each blade of grass is just a quad, but we actually would like it to kind of curve, so we'll do that with tessellation. So let's see, do I guess I'll just leave this, because this is technically the no tessellation instance lit. Okay, well I guess I'll just leave this file, but I think we'll just use a new, we'll just use this same yeah, because I want to test it with tessellation, so yeah, this one's not even called no tessellation instance lit anyway. It would be kind of cool if I could just add tessellation with, I don't know, I was gonna say, like, if I could just include an extra file and it would add tessellation, which might be possible, but oops, I managed to misspell both of those. Okay, and then I'll just duplicate this file. Okay, alright, so I'm just gonna grab the old tessellation stuff here so I don't have to rewrite it all. Okay, so we'll move this up here. And then I'll also need to have tessellation control point, which will have float 3 position, world space, and I think, let's see, well, actually, well, I guess it will have world space because it will have this world space, and then I'll need to have both of the quaternions. So yeah, the root quaternion, and this could be in text chord 1. And then we'll need to have the tip quaternion, and then I'll have to have this card UV. Okay, and we can, I guess it'd be, let's see here. So technically, like the tangent space position, I think. Well, maybe I don't want to hard code this, but technically, like the y coordinate is always 0. So we could kind of combine the UV and the tangent space, or even just pass the UV and the dimensions, and then then calculate the tangent space position in the tessellation shader. But I don't know. I mean, in the tessellation control point, there's no nothing. They don't even interpolate or change any of these values, so it doesn't really save you any I guess cycles or whatever you want to call it for having fewer fields in here. So I don't know if it really matters, but oh yeah. Okay, and then I guess I need to pass the lighting color down as well. Okay, so this is okay, so yeah, what I did here is I put the tessellation factor in the W component. So yeah, that probably is a good idea. Okay, so speaking about the tessellation factor, I don't think I actually passed that through here. So I want to add tessellation factor, and then whenever you change the structure here, we have to make sure we also update it in C# because they have to be the same data format. So to do that, we just need to add one more float. I don't need all that stuff. Okay, so basically I just need to, instead of outputting an interpolator, we output tessellation control point. Okay, so output dot card position and tessellation factor equals 0.4, and then the sprout dot tessellation factor, and then output dot card UV root quaternion. Tip. Route position. And then color. Okay. That's all good. Move this out here, just get it slightly cleaner. And so the only thing we need to output into the interpolator is the color once again. Okay, so gotta get the tangent space position, the UV. Okay, the terrain normals for lighting, which I guess will deal with later. I think I'm just gonna delete all this stuff so I don't leave in legacy code. Okay, so we've got, so basically we know that the root, the tip, and the sprout position are all the same. So we don't have to interpolate it. And the reason they're all the same is because basically every vertex in this mesh just shares the value out of the sprout. So okay, so the position for this, let's see. Actually, yeah, for this instance lit, we don't even need the card UV, now that I think about it. Because, well, okay, later on when we add a texture, we will need it, so I guess I'll leave it. But yeah, for now it's useless, but... Oh. Clean that up. Okay, so what I'm trying to see is this part. So the only difference is we need to calculate the actual quaternion value by doing the quaternion slurp, which is this spherical interpolation. Let me see. Here. Okay, so the first is the root quaternion, and then the tip. Okay, so the percentage between them would be the uv.y actually, so I guess we did need it after all. Okay. So now we should just like spherically interpolate between these two rotations. And I'm hoping it will give us a nice curved card. The worst case is the card will stay straight, in which case, I don't know, we'll have to figure out something else. But what I'm going to do... Okay, so this is what I was looking for. We just need to set a tessellation factor for the sprout. And I'm just going to set everything to 5 right now. That's pretty high, actually. Let's just start with 3. Okay, so something's not working, obviously, because there's nothing on the screen. We're getting an error. Okay, well there's an error in the shader, but it didn't show up. Valid subscript, card position, tangent space, and test factor. Oh, it's because I'm still creating an interpolator's output. Oh, okay, so there's no. Okay. Yeah, right now there's not. The UV is just XY, but what's it? Oh yeah, it's card UV. Okay, actually, I changed the name of a lot of these. Slurp quaternion cannot float, convert from float 3 to float 4. Oh. Yeah, these need to be all float 4s. Oh, yeah, okay. Bunch of silly little errors. Oh, I'm not setting the... Yeah, I'm not setting the anything in the output structure. Okay, so output... Guess I'll grab this. And then the color is, again, the same for all vertices in the patch, so no reason to interpolate. Okay, there we go. Oh, okay, good. It's actually doing what I wanted. You can see now there's a curve to the grass. I was afraid it was going to just be straight, even though we're tessellating it, but no. So yeah, there's a nice bend to it. Let's see. Yeah, that looks pretty good. Okay. I guess we can do wind now. I also need to take... Also, yeah, we need to actually do lighting at some point and textures, but... Okay. But, so let's see. So for wind, basically what we need to do is we'll just use a wind texture like I have before, and that will basically, we'll have like 2 wind directions and it will rotate. I guess basically on the, in the wind's direction. So if we want to rotate in the wind's direction, but the grass, sorry, I'm having a hard time putting this into words. So if we want the grass to move in the wind's direction, then we actually have to rotate it in a direction that's perpendicular to it, and then also perpendicular to the normal vector of the terrain. So okay, well, that's kind of what we were doing before with the turbulence, so it's not that difficult. Okay, well, let's add some properties then. Okay, so we'll want wind direction and how you spell that? Turbulence. And then we'll want wind noise scale and wind frequency. and then wind strength. I guess I should go up here just to be... Okay, and then we'll need another texture. Okay, and then on the shader file, need to add all those values. Okay, so first we'll add I guess let's just put another header for wind. Come on. Okay, and then we'll have wind direction. And you could even set this as a global, probably would be better, but for now we'll just do this. Okay, so wind strength. Okay, and this will be a range from 0 to 1. Because that's just going to be a multiplier to the strength. I don't know, we'll start with a 10th. Okay, and the other two have to do with the noise, so just start it at 1, and then frequency. Okay, so now with all that done, so I guess first what I need to do, it's kind of just, I mean, it's a lot like our previous noise implementations that I've done. Let's see. Try to clean this up. So tessellation, and then this stuff is, you know, very simple lighting. Okay, so actually the wind should go... Okay. Okay, so we actually calculate all the rotation up here, so the wind should go like right here. So float to wind noise sample. Texture to D, wind noise, sampler, wind noise, and this, so the UV for this, I guess, will be the world space position. Which I guess, okay, yeah, we don't really need to use the snapped grid position for this. It doesn't really matter because the wind noise is smooth anyway. XZ. Okay, I guess this is one thing, is that we're only going to be using the X and Z, but normally that's fine. So, anyway, I guess you could use a cube map if you wanted to also vary it in altitude, but I don't think I'll worry about that for now. actually, let's go ahead and make this a little cleaner. So wind, noise, UV. And then we'll add it's the time offset. Okay, so texture samples range between 0 and 1, and we want this to range between -1 and 1, so you can multiply it by 2 and then subtract 1 to do that. Okay, and also, yeah, we only want the red and green values. Alright, so this is like a multiplier to the amplitude. Okay, so we have the wind direction. I guess, let's see. Primary wind axis. So it needs to be perpendicular to both the wind direction and the terrain's normal vector. So and then I need to normalize it. Okay, so float 4. Primary wind rotation equals angle axis quaternion. Okay, so the angle would be something like wind strength times wind noise sample dot x times pi, and then okay, I'll just do that. Okay, so the wind we only apply to the tip, and it's in world space, so we should rotate it after we multiply or transform to world space. So that means it should go last in the, or it should appear first in the multiplication, meaning it's applied last. Okay, and we'll tackle turbulence in a second, but I want to see how this looks. Okay, I saw an error pop up. Okay, well, if we got first, let's take care of that. Warning. Yeah, so I should have, I needed to, first this has to be 5.0, and then I need to say that we require tessellation. Okay, undeclared identifier time. Oh right, it needs to have an underscore at the beginning. Oh, I had an extra underscore there when it's not needed. Okay, so let's add, we'll just use the same noise as the LED noise texture. Probably they should be combined, and then the wind noise should use like green and blue or something. But let's see. Okay, well, let's just see what this looks like. Okay. It's a little weird, but it is working, I guess. Let's see. So This is in the... Okay, so if the wind is in the X direction... Okay, so everything should be rotating in the X direction. It looks like it is. I think one thing is that the noise scale is too high, so it's making them all rotate like independently. And then yeah, the strength is probably too high. Okay, yeah, that looks pretty good, I think. Okay, so the reason I like, well, there are a couple of reasons I wanted to switch to doing it this way, because before we used our wind was calculated in the vertex program, or actually the domain function of the material shader. So basically we'd have to sample this wind texture for every vertex in the domain, but now we just have to sample it once, and then we do like the quaternion interpolation. So it'll be interesting to see if it's actually faster, but the one reason I do like this is because later on when we add like player interaction, all we have to do is add another quaternion into this multiplication chain, and like we won't have to change anything about the instance lit shader. It will already have it support for it. Okay. So now let's add turbulence real quick. So turbulence, I think, is it just needs to be like perpendicular to this primary wind axis, so we can just use the wind direction, I think. That should be fine. Oops, I just realized this is misspelled. Okay, so it's the same except we add in the wind turbulence multiplier, and then we use the Y sample, and then we'll just rotate based on the wind direction. And then we can have we can combine them together. So if I turn the turbulence up all the way, yeah, you can kind of see the grass waving back and forth a little more. All right, so I guess one other thing I want to make sure is that, so the wind direction right now is pointing straight in the X direction, so that means if I turn the strength, yeah, it's all, I just wanted to make sure it was rotating towards the positive X direction. I guess if we really wanted to, I don't know, we could even like take away this part so that it does rotate towards the wind. But I feel like wind kind of has like, you know, it rebounds back and forth. So I don't know if that actually looks better. I don't think so. I mean, yeah, it might be different. Maybe we need to make that editable, but at some point I had an idea to try to make like more like a positional wind system, I guess, where you can have like little whirlwinds. So you'd basically have like a wind vector texture that the grass would sample to see the direction of the wind at each point. I'd like to do that at some point, but for now, I'm happy with a simpler system. Okay, cool. So we could probably move all this into like a helper function so that we can try to clean up this a bit. Probably. Let's see here. Yeah, we should probably take this part, or not the bend, but well, maybe. Okay, well, since we're working with quaternions now, yeah, I feel like maybe this get route bend angle should just return the angle axis quaternion. Let's see. Yeah, so let's take a second to clean this up before we move any further. So for now, we have oh yeah, so I need to add this in, of course. And we don't take care of that, but that's, well, okay. I'll do that in a second. Dimensions. So this, I think, yeah, this should just return the quaternion. Okay, so float angle. Okay, and then here. Okay, and then same for the twist, I think. I don't know if you can all hear that, but it's been like thunderstorming all morning, and heard some more rumblings out in the distance. Okay, and then I think I'll just have like combine all of this into one function. I already had this, which yeah, I think I'll just delete it because it's not useful anymore. Okay, so there should be, let's calculate okay, so we'll take in a normal and a tangent. No, well, do I already have? Okay, actually no. So I don't have the tangent or bitangent. I just have the normal. Because yeah, since we can't use the regular tangent and bitangent because we're like we're kind of deforming the normal vector based on the normal map. And we don't really care about the tangent and bitangent after that because we're gonna just like apply a random twist to the blade anyway, so it doesn't matter if we just pick a random direction. Yeah, so just, but I guess we will need it for later on, so. Okay, so flip 3. Okay, I guess we could just return the bitangent instead of having another out. But I don't know. Usually when I have out arguments, I like to just have everything be an out argument. Okay, and then this noise stuff. I don't know, I think we don't need this function anymore. So calculate wind. Okay, so this needs yeah, the position. And then also the normal vector. Oh, I also forgot the strength. Okay, yeah, since we have so many arguments, it might be better to change this to like a structure, but okay, so input position world space. Wind strength, wind scale, wind frequency, wind direction. Actually, now that I think about it, I think the order here is a little weird. Let's direction, strength. I think turbulence should go next. So direction, strength, turbulence, noise, frequency. Yeah, we could even, I mean, we could technically probably move this whole thing into its own, but... Okay, so the only other thing here is I want to add that random offset. Oh, get rid of all that stuff. And this just adds kind of a slight randomness to the grass position, which is nice because right now they all stick exactly to the grid, which is a little obvious. Okay. Oh, I'm missing a semicolon. Redefinition of tangent. Oh, right. I don't need to have the type argument there. Oh, yeah. This be that. Okay. Okay. So let's see. I turn up the scatter radius. Yeah, we can see it kind of moves. You don't want this to be very high because the grid isn't that big, but I think it's definitely nice to have a little bit in there. Okay. Right, there's still a lot of code in here. All right. So, oh yeah, I need to get the right tessellation factor. And this mostly depends on the LOD level. Okay, so I actually still had it active. So yeah, I can set the tessellation amount per level now. So when it's at this one tessellation factor, it reverts back to being grass cards. So they're kind of, they are flat, not kind of flat. But even just adding a tessellation factor of 1 adds a bit of a curvature to it. Okay. There's all these like little tiny ones. I think they're like that because of the width smoothing. But I almost think, I don't know, I might need to edit that because I almost think that if they're so small that maybe they should just be invisible. Like I should just like cull them once they reach a certain size. Okay, but anyway, so I think technically I could probably convert this entire thing into one helper function. Although I would have to pass a lot of data to it, but I guess I'll have to see. Yeah, because we'd have to pass the wind and everything, so I don't know. That would be very helpful. Okay, I guess one other thing I wanted to do is we have this growth direction, so you can add like an upward bias and then so that grass that's like on this angled terrain would still kind of grow towards the sky. So we would do something like this. Okay, and okay, so you can really only tell here. So if I turn it up, yeah, they start to grow. Okay, that's kind of funny. Why does the lighting change? Yeah, actually, they kind of just like rotate. Okay, I think probably what's happening is when it goes straight up. I think it has to do here when we try to create a tangent. So let's see. Yeah, so if the normal is straight up, then what are we returning here? So well, I guess it would still work. It's just the negative x direction. Oh yeah, I don't know. It's a little strange, but I don't think it actually matters because this isn't going to be like, you're not going to be setting this dynamically at runtime, so. Yeah, I was just making sure there wasn't some other weird thing. Okay, so are we ready to finally get some real lighting and textures? I think so. Okay, so first let's add, I guess, texture. Okay, so the way... Yeah, it's kind of funny. Most of this code I don't need anymore because it was all for wind mostly. Okay. I guess we're gonna need a little file here for, oops, like the properties. So instance lit properties. Okay, and then we're gonna need the the C buffer start and some of this texture stuff. Okay. So for instance lit, there's no reason to have a normal map because we don't calculate normals per pixel, or really this like lighting data map. So pretty much the only thing we'll have is a color map. And I actually want it to be a texture 2D array. I think I can use the same sampler, but let me check. Okay, I had an underscore there, but yeah, it's the same sampler. Okay, and for here, yeah, we'll still have the okay, so this is saying for like the debugging, but we're not even gonna have a debugging. Well, we might still want to get it to work, but I'll leave that off for now. Okay, yeah, none of this stuff, but we do. Oh, I guess I don't have it here, but we will need alpha clipping. Yeah, none of this stuff. Okay, so for properties, we'll have a color map. Alright, I forget what the little identifier is for texture arrays. Let's take a quick look. I guess we could just copy this. Okay, and then we want the color tint. And then the alpha clip threshold. I guess this should be a range actually. Okay, and then in the actual shader, we need to... okay, well this is the shader, so we need to include the instance lit properties file. And then... okay, so to support color, we can just multiply... or to support the tinting, we'll just multiply that in there. And then down here... okay, oh, one other thing I need to do is the card UV should now be float 3 because we'll put in the texture array index in here. Sprout texture index, and since we're going to do that, I need to add it to the structure, and this also should be in the C# class. So yeah, we just need to add one more float. Yeah, and this is there are floats because I don't know, shaders like to work with floats, so the texture array still uses a float as an index. Okay, so then we do that, and then here change this to float 3, and okay, so now I need to pass the UV to the fragment function. Okay, so color sample equals sample texture 2D array, color map, sampler, color map, then input UV. Yeah, the index is actually like a separate argument, which I don't know, I always thought was a little funny, but... and now we need to do alpha clipping, which I think I already had a helper function for. And here. Okay, but this is doing some fancy stuff with alpha to coverage, which we might deal with, but for now I'm just going to do a simple version for alpha thresholds. So clip, so it'd be alpha minus cut out threshold. Okay, let's do this. Okay, and then... okay, so here I can actually just return the color. Okay, so now the last thing I need to do is... and the brighting shader, I need to add... so a number of... I guess blade textures So I think I already have function to get the texture index. Okay. Let's see. Domain is not. Oh, I don't pass the UV through. Okay, I guess that was fine how it was. All right, and okay, so I think I have in this test texture I made, I have 4 grass textures. Okay, this will do. Okay, there we go. We got clipping working. And then yeah, I can apply a color tint. Okay, let's see. Do I have a... Okay. I thought I had another one. Okay, well, I guess the reason it just looks funny is because there's like not yeah, so it seems more green than it should. Oh, that's because in the lighting yeah, so we're only multiplying the green, so the red and blue channels just get destroyed, okay, or zeroed out. So that's why this looks kind of weird. So I guess the next thing we need to do is get real lighting. Okay, so it's not that difficult because we already have the grass file ready. I'm not sure the best way to do it because there's just a lot of like extra little multipliers. Okay, well first I guess let's just make it in here and then we can see, because it might be best idea just to have this file make the lighting structure. Not sure. Because we're gonna have to pass all this stuff. And since it's instance lit, we don't really vary it across the blade, so let's see. All right, so let's just fill in all this values one by one. Oh. Of course, I got the wrong file. Okay, so foliage lighting data. Okay, so the position is simple. It's just the sprout dot position. The normal. Okay, so the mesh normal is what we use. It's supposed to be the normal of the actual card. So it's this value. Do I want to... I guess the question is, do I want it to be based on the root or the tip? Well, I'm going to turn off specular, so basically the only time this would matter would be for translucency. So I guess this is fine. But I want to say that... Okay, well, let me see. I was going to say if the mesh normal and the view direction are more than 180 degrees apart, I was going to flip the mesh normal. Okay, so so yeah, dot mesh normal. Let's not do something fancy. So f dot d view direction world space and mesh normal world space is less than 0. That means I want to flip the mesh normal. That's just because since this is two-sided, I want the side that points towards closest to the view direction. Okay. And then the shape normal is the terrain's normal vector, which would be this value. I guess I need to normalize it. Okay, the shadow coordinate. Okay, I think I set this up so that it can get what it needs to. Okay, so this doesn't really matter because there's not... Can't really do screen space ambient occlusion with instance lit because again we're not dealing with this per pixel. So that, I think screen space ambient occlusion might be, well, I was gonna say it might be something you'd want to do per pixel, but if we did that, then we'd have to keep track of like the direct and the indirect lighting in two different values. I guess I'd have to see. Okay, but for now, yeah, I think we just won't deal with this because we're just going to go pure instance lit. So we calculate all lighting per blade. So yeah. So we can leave that at 0. Okay, so the albedo we actually want to be white. Okay, alpha. Okay, so smoothness we need to actually set from a property. Okay, and the specular strength is 0, so I can just leave that out. Ambient occlusion doesn't matter. Oh no, I guess it does matter because we're still gonna sample the baked lighting, so. Well, okay. No, I guess we will leave it. Okay, so I guess this will be 0 because this is mostly so you can set like a minimum ambient occlusion, so that the screen space ambient occlusion doesn't make your grass too dark. But since we're not even doing screen space ambient occlusion, that doesn't matter. Okay, so subsurface color. This is all for translucency. Scattering strength, I guess, might be something that would be visible. Okay, so baked GI. Okay, I've got to do this annoying thing to support both Unity versions. Okay, so yeah, we don't even get the light maps down here, do we? Oh, no, I do. Okay. Okay, so D dot subsurface ambient strength. This is like a, let's think of it, kind of a constant glow. And environmental reflection strength. Okay, I guess okay, and then the shadow mask. Vertex lighting. Okay, I think we. Oh, oh, okay, I do. Okay, so the only other thing is I have to do all this stuff for debugging. I guess we can worry about that in a second. Okay. So the tint here would just be calculate foliage lighting. All right, so now I need to figure out all of or add properties for all these new things. Okay, and now I need to add properties in the shader. Let's, I guess, make another header for lighting. Okay, smoothness. This is actually a range. Okay, let's just add a bunch of them. Oh, it was perfect. Okay, so ambient occlusion, subsurface color. Oh, and yeah, that should actually be a float 3. That should be 1. Thinness. Scattering strength. This is like when it tries to calculate translucency, so if the normal vector is like perpendicular to the view direction, the less light can get through the surface, which is kind of what this value models. Okay. Valid subscript position. Oh yeah, just need to have a capital S. All right, let's see how it looks. Okay, so all black. That's not what I was hoping for. But I guess it's better than an error. Okay, let's see. How can we... one thing let's see. Did I should not have screen space ambient occlusion enabled here. Okay, which I don't. Okay, so that's good. I just want to make sure because I thought maybe that's why that was all black, but... Okay, so yeah, obviously it's like just pure black, so something is not being set correctly. I'm trying to think what would be the best way to test this. Just to pure like baked GI and see. Oh, okay. I just need to add a fourth component, so okay, so the baked global color is working, although I don't know why. I guess the light map's probably out of date. Yeah, because actually it doesn't even seem to actually be showing up correctly. Although these are tinted purple, but these aren't tinted red, and I don't know why these are randomly red. Oh wait, this is, yeah, that's a real-time light, so okay, that one's banked, so, or baked. Okay, this is actually real time. Okay, so I'm gonna, I guess, generate some new lighting. So sorry if, usually it doesn't really matter, but the GPU can handle it. But if there is a little stuttering, that's why. Okay, it's almost done. Okay, yeah, it's just finishing up. Okay. Okay. So I guess, yeah, the light map is there at least. Okay, so I think the light map is working because you can definitely see that these are pinkish and then these are more green. I don't know. I feel like these aren't getting shaded though. And this is a real-time point light, so that should definitely be happening. And these aren't getting shaded blue. So I think an issue is with the real-time lights. I don't know why these are red though, which is kind of strange. Does that have to do with the light probes, maybe? But grass shouldn't be affected by light probes. Oh, okay. That is actually what's happening, because this sphere is not static, so it's affected by the light probes. And since, and then the grass is just gets its global big data from the terrain that it's on. Okay, so I think that's probably why. So if I move this, maybe they'll, yeah. So if you move it away, then yeah, it starts to change color. Okay. I'm glad that mystery is solved. Okay, so big GI seems to be working, but it's the real-time lights that's not working, so I wonder if it has to do with the normal vector. Okay. Okay, so this is red, so that means the normal vector is pointing in the positive x direction. But it should be flipping based on the world. or based on the view direction, because that's how I wanted it to work anyway. Oh, well, actually, so okay, so the mesh normal doesn't even. This might be a problem with something, but that's not even what deals with the diffuse lighting. It's this shape normal. So okay, so this is all green, which means it's all basically pointing straight up. Okay, so that's fine. Then why is this black? There's no debugging stuff on, so... Okay, and if ambient occlusion is turned off, then it doesn't even adjust the light color. Okay, so I'm going to just have it return... Okay. Yeah, I'm just gonna only have it do the main light color before it does anything else and see what happens. Okay, no, that will work. Wait, no, it doesn't work. Okay, so it's getting some light, but I don't know why all the blades aren't, because oh, well, the main light is okay. Yeah, the main light. Okay, I think I know the reason now. The main light is pointing in a weird direction, so we're actually getting like just a translucency from it. So what I need to do... let's see. That's not what I wanted either. Okay, so this works, and it's also getting shadows. You can see, like right here, that the entire blade is in shadow, even though part of it's not, and that's because, again, it only is calculated from the center of the blade. Actually, have two, I guess, a test. Directional are to test the translucent and non-translucent lights. Okay, although it looks like that's gonna mess up some of the skybox and baked lighting probably, so let's not do that. I'll just have to fix those things myself. Okay, so maybe the whole reason it wasn't working was just because the main light was in a weird place. Well, we still should have gotten lights or lighting from additional lights. Okay, so now it's all black, so something happens to it afterwards. Is it... Okay, if I... Well, that shouldn't be it, because I don't... I mean, it doesn't do anything if screen space occlusion isn't on, but I guess just to make sure. Okay, no. Alright, so let's just see. What would be... Okay, I guess I'll turn off ambient occlusion? Or turn off global lighting? No. Wait, is it like... Okay, maybe it's this rendering layer thing, but it should always return true. Because I don't even have... Yeah, we're before this version. So that shouldn't be it, but let's just see. Okay, no, like I thought. Then... why... Is it fog, maybe? Okay, let's just turn off everything except the main light. Okay, so that works. Now let's just turn one thing on at a time and see what breaks it. Okay, so something about additional lights breaks it? Why? Okay, why is it turned black? Because all we do is add to it. Is there any way this could be negative? Okay, so we saturate this. Hmm. Let's take some of these terms out and see if one specific thing is causing the bug. Oh, this is gonna... Okay, I think that will work. Okay, no, it's something in the diffuse. Okay, so diffuse is always between 0 and 1 because of the saturate. So that would mean something in the radiances. Can distance and shadow attenuation be less than 1? Okay. So why is... So it turns black, so that means that... And when I saturate this term, it goes away, so that means that one of these is being set to negative on the additional light. Which is really weird. I never... Okay, let's turn off... Okay, I guess one other thing I can try. Let's turn off some of these lights. Okay, so for some reason the spotlight is messed up. Why? Okay, it doesn't like the shadows. How strange. Let's see. Okay, I don't think this really has anything. Well, I guess I was gonna say it doesn't have anything to do with my system, but here, I mean, it's getting lit correctly on the sphere. And actually, the soil is getting lit correctly. Does Unity saturate the shadows or something? Is it something I should be doing? Let's see. I guess it would be where it does the lighting. Okay, so yeah, this passes the color, direction, and attenuation to that function. So if we go down here, okay, so apparently it has a overdrive or override with the light structure. Okay, here and trying to see where it converts it. Okay, so color. No, it doesn't saturate it. Well, what is going on? This is really strange. Oh well, I think I'm gonna have to think about this one and see if I can figure out what's going on. I don't know why. It's something to do with this light, apparently. Because when I either turn off shadows or just disable the light, everything works. Okay, I guess this one can't have shadows, so it won't do anything, but this light's not affecting it anyway. Oh, that's baked. This one's real time. But yeah, it's working. So what about when I have that one off, but then this one on? Then it works. Okay. Oh, maybe this is that weird light bug. Okay. I don't know why, but sometimes there's a really weird bug with extra lights in this 2020.3 where sometimes if you have a bunch of lights, some of the values just get corrupted. It doesn't seem to happen to the lit shader, but it does to custom shaders, and I don't really know why. Because it uses the same code, but I think people have also complained about this in the tune shader and stuff. But I haven't worried about it too much because I haven't been able to really reproduce it, but Okay, and see there it just fixed itself because I just created a light and then destroyed it. Let's see, so is it? I just want to make sure that's actually lighting or affecting the light on the grass. Yeah, it is, so... Okay, well, now it is working. Okay, so yeah, if you ever have a bug like this, okay, and it's back now, but I could just create that and then delete it. Yeah, so I don't know. It's a weird bug, but it doesn't work. It doesn't happen as much in newer versions, so. But I guess to fix it, we could just saturate the shadows. So. Now that I think about it, it probably has something to do with a keyword for, like, if you saw, there's like a bunch of different ways to. Where was it? I really appreciate when they split this file up into multiples in 2021.2. But oh yeah, so how's what I do with this use structured buffer for light data? Although it's not a define, so I don't even have to do a shader variant, so I guess not. But anyway, it's a strange. I thought I was finally behind it, but reared its head again. But anyway, so we've pretty much got lighting working now, and and shadows. So I think we're ready to maybe move on to making some better lighting for the grass. So we can do like instance lit. No, we have instance lit. We can do the fragment lit version. And I kind of want to try like a hybrid where we do lighting on the instance, but then we try to do, I don't know, like ambient occlusion in the fragment function. So maybe we'll try that, but I think we're finally starting to get to the end of this. So what will maybe we'll try to do some interaction, something like that, or maybe that fancy wind system I talked about. But yeah, there's still a ton that we can do to grass. But I think I will go ahead and wrap up for today. Thanks everybody for coming by. I really appreciate it. I know I usually don't stream on Saturday and we had those tech issues, so thank you for everybody who dealt with that. But I'll be back on Monday, same time around 2:30 US Eastern time, and we'll probably work on this some more. Yeah, maybe try out some of those other ideas, but we'll see. But I hope you have a great weekend, and I'll see you Monday. Bye-bye.